Hello everyone, welcome back to the last question for the AP Calculus AB exam in 2024. This is question 6, and with this we will end the video series on AP Calculus. Alright, so let us go out with a bang and solve question 6. Now question 6 is, it's more of a concept based question rather than a calculation based question, because in two of the subparts A and C you can observe that they have just asked you to write the integral and not calculate it. Alright, so that means they want to check if you know the concepts of rotating solids as well as the area of curves under the integral. They are not expecting you to evaluate the integrals, but it's enough just to know the setup, and that will fetch you full marks. Alright, so first look into the graph. The graph has two functions, fx and gx. So fx is above gx, so that means fx minus gx would be positive. Alright, remember this fact, we will use it later. Now fx and gx are defined as x square plus 2 and x square minus 2x. Well, x square plus 2 is always positive because x is positive, so x square plus 2 will be positive, and x square minus 2x can be negative, and it has a solution at the origin as well as 2 comma 0. Alright, so you can see that it intersects the x-axis in two places. Now let us dive into the first part directly. The first part says, let R be the region. Okay, let me read the question. Let R be the region bounded by the graphs of f and g. Alright, so from x equal to 0 to x equal to 2. Alright, so between the portion where y equal to gx was in the fourth quadrant, we just have to calculate the, well, we do not have to calculate, we just have to give the integral that represents the area of the region R. Now I told you, right, fx is an increasing function because it's x square plus 2 plus it's always positive, and gx is, well, x square minus 2x. So fx will always be greater than gx in the interval of 0 comma 2, as is evident from the graph. Therefore we can easily solve the first part. We would just have to write the integral, right? So area of R will be equal to, the integration will be set from obviously x equal to 0 to 2, and we'll go fx minus gx dx. We could have had this modulus sign if we were unaware of the situations representing fx and gx or their positions, but since we are aware of it, I would not use the modulus sign. It's not necessary. So this is more than enough. Right, they have not asked us to evaluate it, so we can actually leave it here and obtain the full marks. Okay, you can write modulus, you may or may not write it, does not matter, you will get the full marks. All right, the next portion says, let S be the region bounded by the graph of G and x-axis. All right, so we will look into the portion S. Now the portion S extends from x equal to 2 to x equal to 5 as shown in the graph. It is the base of a solid. For this solid at each x, okay, so at each x the cross section perpendicular to the x-axis. So here, if it is a solid, you would have to assume that the solid extends towards the z-axis. Okay, so this is a 2D plane, right, like this, and you have to assume that the solid is stretching out from the paper, it's hitting you in the face, it's sort of a building structure. Now what does it say? It says that for this particular thing you would have to assume that the cross section perpendicular to the x-axis. All right, so this is the cross section technically, right? When you build the solid, it will pop out of the page, is a rectangle with height equal to half the base. So what is the base? The base is gx, right? So we are creating the solid on the base of gx, and the height is supposed to be half of that, equal to half the base. Now if the base is gx, then the height will be half gx. Agree? And what is the area of a rectangle? It's half base into height. Now once that is done, we would just have to integrate it and it will be done. Okay, so area of solid with base S, this will be equal to, we have to integrate from 2 to 5, right? This will be half of gx, that is height, and base, which is just gx dx. So, well, volume. Volume, because we are integrating the cross section. Okay, we are integrating the cross section. We are actually taking the vertical cross sections and integrating it horizontally instead of taking the horizontal cross section and integrating it vertically. Um, Make sure that you appreciate this difference. Try to picture a cylinder. All right, when you calculate the volume of a cylinder, you take the cross section to be a circle and then integrate it vertically, right? Here, instead of doing that, we are taking the vertical cross section, which would be gx at the base and half gx in its height as given in the question, and we are integrating it horizontally. Alright, so there are always two ways of calculating area. You can either take the cross section and go up, or you can take the vertical cross section and go sideways. Okay, I hope you appreciated this point. Alright, next. So this is v equal to, just calculate this, right? So half can be taken out and we would have 225 g of x whole square. G of x is given to be x square minus 2x, right? So x square minus 2x whole square dx. Now this is just a simple calculation. We should not have much trouble with it. 225, this will be x to the power 4 minus, this will be 2x cube 4x cube plus 4x square dx, right? Yeah, so integrate it. It will be half into 225 x to the power 5 by 5 minus x to the power 4 plus 4 by 3 x cube. Well, if we integrated it, I should not keep this. This will be evaluated from 2 to 5, right? Sorry, I should have used the square brackets. Now it's just calculation and you will get half of 5 to the power 5 by 5 is 5 to the power 4 minus 5 to the power 4 plus 4 by 3 into 5 cube, right? These two cancel, and then minus 2 to the power 5 by 5 minus 2 to the power 4 plus 4 by 3, 2 cube is 8. So if you solve this entire thing, it will turn out to be half into 500 by 3, right? Because 5 cube is 125, 125 into 4 is 500 by 3 minus, this one will be 2 to the power 5, which is 2 to the power 5 is 16, 32 by 5 minus 16 plus 32 by 3, you can solve it, it will turn out to be 16 by 15. Alright, and if you solve this, ultimately it will become 414 by 5. You can leave it here, you don't need to transfer this into decimal, this will be the correct answer. Okay, I hope you understood how we sliced the solid and calculated its cross section area. Alright, solid means it should be a 3D figure. Okay, now the next portion is again a bit complicated. Complicated in the sense that there is no large calculation, but you would have to picturize the solid that is getting created. It says write but do not evaluate an integral expression that gives the volume of the solid generated when the region S, okay, so this curved half triangle thing is rotated about the horizontal line y equals to 20. So what happens if I rotate this around y equals to 20? What kind of shape will it form? It will form a circular thing because it's getting rotated 360 degrees, right? Now if it is getting rotated 360 degrees, then we would have an inner circular part and also an outer rectangular part, right? Now by rectangular part I mean a vertical part where you have a corner, right? Which you can see that at the point 5 comma 0 there is a perpendicular there. So if we rotate it, that corner will remain. Okay, now we are rotating it about y equal to 20. If we are rotating it about y equal to 20, then there is a lot of white space in between, right? That white space will not form the part of the solid, isn't it? So we have to subtract this portion around the solid. Okay, let's go. So what will be the entire part of the diagram at first? If we rotate just the line y equals to 20, what will you get? First we have to take the entire block, okay, the block that is from 2 to 5 stretching till y equal to 20. Okay, we have to rotate that entire block first and then remove the white space. That will give us the area, the volume of the portion, right? So volume of that block, that will be, we will rotate it the entire 360 degree, so that will be 2 to 5, and the cross section area of that will be pi r square, and here the radius is y equal to 20, right? So we are rotating it like this, so it will be pi into 20 square dx. Alright, so this turns out to be pi into 2 comma 5 20 square dx. Alright, now we'll calculate the area of the white space. What is the white space? The white space is the region that is not the area of gx, right? So by same logic it will be pi into, again we will use the circular logic, so it will be pi into 20 minus gx, r square obviously, dx. Okay, understand this part. So the area of the white space, if I mark it, it will be this portion, right? Y equal to 20, if I subtract it from gx, gx is basically this portion s, right? Now since we do not have a particular shape for it, we would just be subtracting the white space from the portion that we already know, which is y equal to 20, to get the volume of the portion inside the region S when it's rotated. Alright, so this green portion is the white space, and in 2D terms, what is this? This is 20 minus gx, right? So between 2 to 5, 20 minus gx will give us the area which is not gx, and y equal to 20 will give me the entire area. So 20 minus gx will give us the area of S, and when we integrate that in terms of volume, we will get the volume as required. Alright, I hope you understood this part. So this is 20 minus gx whole square, which is pi into 2 to 5, pi constant again, 20 minus gx whole square dx. So required volume V will be equal to, pi will be common, right, if I subtract them. So 2 to 5, 20 square minus 20 minus gx whole square dx. Simplify this a bit and you will get your final answer. So this is 2 to 5. Now this will be 400 minus 400 plus 2 into 20 into gx minus g of x whole square, and I can put that under brackets dx. So this will get cancelled. This will be 400. I know the value of gx also, right? So this will be pi into 2 to 5. This will be 40 minus gx. So gx is x square minus 2x into 40 minus x square plus 2x. Right? You can leave it here. Right? Any simplification after this particular step would have given you the full marks. Okay. Now technically we can integrate this. Of course we can. It's just an algebraic integration, but they have asked us do not evaluate. So why would we? Okay, I hope you understood this problem. As you can see, this problem was actually not that difficult. There were no calculations involved except in part B. Part A was extremely easy. Part B had a bit of calculations, but they were mostly rational numbers, so you would just have to do a few operations on fractions. Part C was conceptually a bit tricky. You would have had to realize that you cannot fix the shape of S, so you cannot use its cross section to calculate the volume of the rotated part under the reflection of y equals to 20. You also could not do it because there were some white space. So if you rotated gx around 20, just gx would have given you a weird shape because you did not exclude the white space. Alright, so that would not have worked. So what we did was, from y equal to 20, first we took the entire block. So if we rotate that entire block, it will become a donut, right? We have a portion which is getting rotated 360 degrees. So it will be basically, the cross section will be a circle, and we would have the cross section as pi r square. Y is 20, so this radius is 20. So that is how we get, I have written it quite simply. So v is volume, right? So v of the volume of the entire block would be pi into 20 square, pi r square, and its integration from 2 to 5 would give you the volume. The volume for the white space would be something that is not gx. So in between y equal to 20, there is some portion of gx. Now why am I mixing y equal to 20 and gx? Do not get confused, because x is the independent variable and gx is the dependent variable, right? So anytime I take gx, it's basically the y coordinate upon inputting the x coordinate as x. So any point on gx will be represented as x comma gx. Okay, that is from basic calculus. X is the independent variable, gx is the dependent variable. So clubbing y and gx is not a problem because both of them are dependents. Okay, so white space is basically 20 minus gx. So the entire block that is not gx. Alright, now again the volume of that rotated will be 2 to 5 pi into r square, so 20 minus gx whole square, and that would give us the v of white space that we have done. So required volume will be v block minus v white space. We just simplify it for 2 steps and we reach at this point. Any simplification after that particular point will net you the full marks. Alright, so you don't need to worry about further calculations. You can do it, but if it is not required, why waste time? Okay, there will be no extra points for you if you have tried to attempt this solution. It can be done, it's quite easy, it's just a polynomial integration, and it will also take quite a bit of calculations because there will be 6 terms. So you would have to place the values there, and you do not need to multiply pi, you can keep pi separately. Okay, anyway, this was a bit tricky, not because of the calculations but because of the concepts. I hope you understood what I have tried to explain. If you do have any questions relating to this particular question, or if you want a thorough revision of calculus to aim for attempting the exam next year, or in the previous section, if you did have any doubts, you want to clear them up, do not hesitate to contact the number that is given just below my face, man. You can drop a WhatsApp there with your query and our team will get back to you. Alright, if you do have any comments, suggestions, feedback, you can use the YouTube comment section. Do post your queries there. Our contact details will also be present in the YouTube description box, so you can use that as well. Alright, so we have completed all 6 questions from 2024. Let me know if you want me to go through the detailed solutions of the 2023 free response question as well. If there is enough demand, I will do it, no problem. And that's it. I'll end this video here. Thank you all for joining. Thank you all for staying with us throughout the series. And as always, if you do have any queries, do reach out to the number, drop a WhatsApp, and we'll take care of it. Okay, bye. Take care, everyone.